All right, continuing from where we left off, let's go ahead and jump into the database testing code that we want. Let's close all these. So let's go ahead and create a new Java class. I'll call this an integration test because our default service factory does need a data source, which is a database connection, which means it should be an integration test and not a unit test. Okay, so let's add test. Do we actually have test dependencies in here? Yeah, okay, when we created this module, we left in our test dependencies. So we only have one, well, we have a couple methods in here, but we can test them all at the same time. We've got these two methods, so we can do service factory, default service factory. I need a data source for this, which we currently don't have. And then we can do just assert not null, the list, and the item. So we'll just verify that our default service factory actually returns objects for these. Now we need a data source to pass in here. So there's our data source, but now we need to actually have our testing framework, JUnit, to provide this data source for us. So for that, we actually need to create an extension to JUnit. Let's do a new Java class. We'll call it data source extension. I think we want to, I need to spell it right, implement, well, before all, we'll do a before all callback, before each callback, and we want a parameter resolver. Okay, so those are all JUnit extension API interfaces. Let's implement all these. So basically, this method's going to be invoked before all of our tests run. This one will be invoked before each individual test method is run. And then these two methods will be used to provide access to our data source. So we're going to need to create a data source. So we'll do a new data source extension. So this is where Hikari comes in. So let's create a new Hikari config. Oops. There's a bunch of sets in here. Yeah, we want all 4 of these or 5 of these top ones. So for our driver, we're going to use the org.sqlite.jdbc driver. So this set driver class name takes the name of the class, so that should provide that. We want to set a username. We want a password. We can probably leave these blank. I'm not sure about that. We want a JDBC URL. I'll come back to that in a minute. And we want to turn off auto commit if it's turned on. We'll manage our own commits as part of our own transactions in our service. So if we come back over here to SQLite, or let's just Google it. SQLite, JDBC URL. There's a lot of good example SQLite information at the SQLite tutorial webpage. Yeah, so I scrolled right down to this. JDBC URL can be used to create an in-memory SQLite database. So let's copy that. Let's paste that here. And so now that we have our config, we can say data source equals new Hikari data source and pass in our config. Before any of our tests run, we want to use Flyway to configure our database schema. So we'll want to, we'll set the location for where our schema information can be found. So this is by default it defaults to DB migration. And I'd like to change it to something other than the default just in case some Flyway SQL scripts make it into my dependencies. So I'll change it, I'll add a to-do on there. We haven't done it yet, but we'll need that directory in our source main resources, and we'll put our initial SQL script to create our tables inside here. What else do we need to set here? We need the data source. We are going to load and migrate at the end. Is there anything else in here? Like there are so many methods in here. Like you could set a bunch of these, like connection retries. We're not going to use schemas, but if we were, then we could specify those. Encodings. Like there's a ton of configuration we could put in here, but we don't really need any of that. We'll just do this for now. We're not going to throw any exceptions, so we can get rid of that. Same here. So before we run each test, we'll do a database cleanup. So we'll do new SQLite to-do item service with our data source, and then we'll just call truncated. And same for our list. Now, if we had more implementations than SQLite, this wouldn't make sense. We'd have to figure out exactly, which data source we were using, or I should say, which service factory we were using, and use it. And in fact, we should probably go ahead and do that. Let's do new default service factory. Let me do service factory dot. Yeah, we don't need those. So there we go. That's a little bit more flexible. That way, if our default service factory is updated to add support for different types of backend data stores for this to-do information, then we can still truncate it through these interfaces. All right, so to determine whether this extension supports a specific parameter, we can check parameter context .get parameter .get type .equals data source .class. So if any of our methods, like this one, or I should say constructors, need an object that this extension supports, then this extension will return it. So it basically looks like that. And we're not actually throwing anything, so we can get rid of that. So basically, if we up here say extend with data source extension, then this extension will be used to provide this parameter, because this extension implements a parameter resolver and it supports parameters of type data source, and it will return this data source that we've created up here. So this extension is going to provide this data source so that we can use it in our test. In fact, let's go ahead and run this and see whether it works or not. Okay, so the test did work. We got a bunch of red here from Flyway. No migrations found. This makes sense because we haven't actually created any migration scripts yet. And we've got this logging stuff. Let's go ahead and add logging support to our database here. So let's add our logback, not audit server, we want logback classic, and we don't need a version. And we're only using this in test scope. So I'll add that, so that way we get logging during our test, but we don't, this dependency isn't required outside of tests. So now if I run this again, I didn't add, let me go ahead and add a logback resource. Let me get one from REST. Logback test. We don't have an access log here, so for tutorial API, I'll make that info. We don't have Jetty. We do have org.flywaydb, and we've got com.zaxer for Hikari. What else do we have? We have SQLite. So let's go ahead and run this. Okay, let me do a Maven reload since I added that logback. And then we'll kick this off again. Okay, there we go. So now we've got some good logging. We've got some Flyway. O.f is org.flyway. So we got some Flyway stuff here. We've got more, all that is Flyway, and then we get Hikari creating a data source. So yeah, everything's looking good here. Let's close that down. Let's close this Palm down. Our default service factory test is looking good. Our extension seems to be working. It did provide a data source to our default service factory, so everything's looking good. Before we start looking at our services, let's go ahead and create a new Flyway migration schema. So the format of this file name is important. I'm going to do dates. So today is November 25th. So the file name should start with a V for version, and then it should have a lexicographically sortable version name, basically. So you can do like V1, V2, V3, or V01, things like that, or dates, which are sortable as well. Then you have 2 underscores, and then some additional metadata about this SQL script and what it does. So I'm going to say initial schema, or DB schema. And it's a SQL file. So in here we can define our create table statements. So we'll do create table if not exists. We want to-do lists. And we'll have a couple fields in here. We'll have an ID field of type text, not null, primary key. And we'll have a list name, I think. Yeah, we have these fields in here. Let me close that. So yeah, we can use a name. And we'll require our name to not be null also. We can create indexes on this table. So create index, what do we want to call it? I guess to-do lists, ID, index. I guess we could do name as well. Excuse me. Now, okay, something else that we're going to want is the user ID, or the ID of the user, the Rapid API user that owns each to-do list So we can only have one primary key. So let's actually get rid of that and make this a unique index on user ID and ID. And I botched this name here. Call it name index. Okay, well, we actually don't need a name index. We're not going to be searching lists by name. We're either going to be getting them all or fetching them by ID, or user ID and ID. So we can create, let's call this user ID, ID index. Then we'll do an ID index and a user ID index. Potentially just having an index on both fields will create like child indexes on the individual fields. I'm not sure how SQLite manages that, but we'll go ahead and just create a bunch of them. They're relatively cheap, I guess. All right, so we've got our to-do list. Let's also create a to-do list items, or maybe to-do items. So each to-do item will be part of a list. And each item will have its own ID. Let's see what we have in here. Yeah, it'll have a task and then a boolean whether it's done or not. And so we'll need a foreign key constraint to connect our list ID back up to our ID up here. And I think we will also need a user ID here in our foreign key, just because technically what's unique, actually we don't want unique here or here. So what's unique is the pair user ID and ID, not necessarily one individual of those. So we'll do our foreign key constraint with user ID and list ID back up here. So we'll do I kind of forget the syntax here. I think it's constraint, and then you give it a name like to-do items fk for foreign key. We can give it whatever name we want, but I like having the table name and the fields in there so that we can delete it if we need to, things like that. To-do items foreign key user ID, ID or list ID, foreign key references to-do lists. Let's break this up a little bit, I guess. And then we can do on update cascade, on delete cascade. So that way if like an ID gets updated, then it will cascade down and update the list ID down here. Or if a list gets deleted here, all of its items will get deleted also from the delete cascade. All right, so we can have similar indexes to these. We'll have a unique index on to-do items, user ID, list ID, and ID itself. On to-do items, let me update those. So user ID, list ID, and ID. All right, we'll have one of these, one of those. Okay, that seems pretty good. So we've got 4 indexes, one for the combined, for our unique, our primary key. We could probably also do constraint to items PK, primary key, and then we could get rid of this unique constraint. I think that's how that works. Let's do the same thing up here. Alright, and we can get rid of this. If I remember, this is the correct syntax. I'm kind of doing this for memory a little bit. Alright, that seems like it's okay. If it's not okay, we should get errors when Flyway runs. In fact, let's go ahead and run our tests here. Run all tests and see what happens. Okay, so everything seems to have worked. It found our schema that we've gave a version of today's date, and then it picked up our metadata from the file name. So everything looks good. It successfully applied that schema. So it worked out pretty well. Typing this stuff in from memory, I guess. All right. So that's that. Now we can go and start implementing our actual services to talk to our database now that we have our database schema created. So we'll pause here and we'll pick up on the next time doing that database implementation.